All right, so we're looking at vertical asymptotes. In particular here, we have ourselves a lovely rational function, and we're going to start by asking, hey, what's the domain for this thing? So we see that we have a trinomial in the denominator, a quadratic polynomial, and so we say, okay, maybe we can factor it. Can we think of factors of negative 32 that would add to positive 4? And we say, why, yes, we can. That's going to be x plus 8 times x minus 4. So we know right away that we're going to have to throw out of our domain negative 8 and positive 4, because when we plug those in, we will have a divide by 0 error. So we're going to have all real numbers except x can't be negative 8. And x can't be 4. Okay, next up, what's our y-intercept? And we're going to say, okay, well, that of course is f of 0. So we've got 0 plus 5 over 0 squared plus 4 times 0 minus 32. So it's going to be 5 over negative 32. So that means our y-intercept is 0, negative 5 over 32, which doesn't really reduce, so we'll just put that around here. Our y-intercepts, of course, sorry, not our y-intercepts, are the points that we had to exclude from the domain. They are not common factors with the numerator, so they are going to both be vertical asymptotes. So we'll have x equals negative 5 and x equals 4. Sorry, x equals negative 8. And x equals 4. So we'll put those roughly vertical asymptotes in here. There we go. And then we're going to say, okay, well, where are our x-intercepts? And for this, we only need to look at the numerator, because if the denominator is equal to 0, then that's a point that we need to throw out of the domain. If the numerator is equal to 0, then the whole thing is equal to 0. So we're looking at the numerator only. So we want to know where x plus 5 equals 0. So of course that's going to happen at negative 5. Okay. And so we actually have a pretty good idea of what this function looks like in the middle, because we know it is negative at x equals 0. We know it's equal to 0 at x equals negative 5. And it's a single root, so it's got to cross through. So we can kind of sketch this, maybe. Oops. We'll just pretend I kind of hit our points here. We'll just make it bigger. So there's part of it. Now, we do have the function existing above 4 and below negative 8, so we can use the, just pick a point and find the sign. So if we plug in 5, for instance, we're going to get 10 over 25 plus 20 minus 32, which is something positive, and that's all that I care about. We know that we're going to see asymptotic behavior, the function going up to positive infinity or down to negative infinity. We know it's got to be going up to positive infinity because it is positive at 5, x equals 5, and there's no more zeros, so it can't cross the x-axis to get into negative territory. So we know it's got to be doing roughly something like that. And then we can say, okay, what is f of negative 10, right? So we have negative 10 plus 5 is negative 5, and we've got 100 minus 40 minus 32, and of course that is a negative over a positive, so it's going to be negative there. And so same reasoning here. We know as we get close to negative 8, our function is going to be going towards positive or negative infinity, but there's not an x-intercept on this first leftmost portion of the graph, so it can't cross from negative territory at negative 10 to positive anywhere else. It's got to stay negative. And then, of course, we can verify that our graph is correct by, we can go ahead and graph it, y equals x plus 5 over x squared plus 4x minus 32. We're going to have to do a zoom to fit. That did not do a good job. Why am I not surprised? Let's do this. There, that looks better. And we can see that we got our asymptotes correct there as well. So that's really all that we have for this problem. We've got another similar problem coming up for second example in the next video.